So we're going to look at 2.1. We're going to now look at question number 1. And question number 1, all you need to do is write out your ordered pairs. And when we read a table like this, the x is first, y is second. So x is going to be the month, y is going to be the sales. So let's see what we've got here. X is 1, and what does it match up to? The 720, okay? Now, x is first, y is second. So it looks like if I write them all out, I've got 2, 180,000, right? 3, 1,060,000, okay? And 4 is 300,000. So it looks like it would be answer what? Answer A, right? Because x goes first, y is second. So all you need to do is just simply write out the ordered pairs. That's it. Question 7 has variables instead of just numbers. And they're going to work the same way. And it's pretty easy to find the midpoint. Because for our midpoint, our formula is just simply add them together, divide by 2. So we're going to add them together, and we're going to divide by 2. We label our ordered pair, or ordered pairs, x1 and y1, x2 and y2. And now we're going to fill them in. So take your time. Now we're going to add these together. So that's going to be a c minus 5c over 2 and a y plus 7y over 2. All we need to do is just combine like terms, and that's it. Now, if this would have been find the distance, it would be a much, much more complicated question. I did not give you that one, because that would make you FOIL things out and work through things. But finding the midpoint for these is actually very simple. All you have to do now is put them together. So c minus 5c, that's a minus 4c over 2. And y plus 7, that makes it an 8y over 2. Break it down, and that makes it a minus 2c, minus 2c. And 8 divided by 2 is a 4y. So that's all you need to do for your midpoint here. Okay, so that's it. So not really much at all. It just looks more complicated because you got the variables, but it's no different than numbers. If it was the distance, it would be a difficult question. But I don't give you that one because that one would make you FOIL, work through a lot of extra parts. This one is actually fairly simple. Plug your values in, combine like terms, reduce it down. And 2, there's a lot of these that have you find the center and the radius of the circle. I think there's 5 of them because there's 6 through 9, and I think in 10 is the same thing too. It's just different directions, but 10 is also one of these. So you have several of them. I'm going to work out questions 6 and 9. Now, what are we going to do? We're going to have to complete the square. And when we complete the square, what do? Half, right? Divide by 2, square. So half the number, square. So let's look at question 6. we're going to be finding the center, and we're going to be finding the radius here. I'm going to go ahead and move that 13 over. So I'm going to rewrite this first by moving that 13 over. So that's the first thing I did, was I just simply moved that 13 over. So always make sure all the variables are on the left, the constants, the numbers are on the right. Now we complete the square. And remember, what do we do? Half square. So that's going to come down to be x, and half of 4 is a 2, and 2 squared is a 4. Box it so you don't lose it. The y part, we do the similar process. For the y part, we've got y squared minus 16y. Half of 16, and it's negative. So half of a negative 16 is a negative 8. When you square a negative, it becomes a positive. So always it will be positive. And 8 squared is a 64. Is everyone all right with that so far? Okay. Now, put the pieces back together. See what we've got. Putting the pieces back together, we've got x plus 2, quantity squared, y minus 8, quantity squared. Now, we have a 13 that's already there. We have a 4, and we have a 64. And we're going to add those all up. So 13 plus 4 plus 64, that gives you an 81. And this is a circle. Now, how do I know that this is a circle? Let's review that. I know this is a circle because this 81 is what? Positive, right? Okay. So, what would the center be? We switch our signs. Minus 2, positive 8. And your radius, okay, square root of 81, which is then 9. Is everyone okay with that? All we're doing here is halving and squaring. If you could remember half and square, you'll be fine. When you find the center, what do? Switch the signs. Just a few things to remember. Question 9 is the hardest one. Because question 9, we're going to have to divide everything by a 5. And that may or may not induce fractions. I don't know that it will. But for question 9, we're going to have to divide everything by a 5. And I'm going to move that 60 over. So that 60 gets moved over first. Now, why do we have to divide everything by a 5? Because it has to be x squared by itself, y squared by itself. These will always be the same numbers. In this case, they're 5s. So I'm going to divide everything by a 5. And it may induce fractions. It may make fractions. This one doesn't, though. So it's just going to come out to be whole numbers. So we're lucky there. And let's see what we get. We get x squared plus y squared. And then we've got 20 divided by 5. That's a 4x. Minus 30 divided by 5. So that makes it a minus 6y. And 60 divided by 5, that should be a 12. Now we complete the square. So for the x part, we've got x squared plus 4x. So what do? Half and square. Okay. Yep, x plus 2. Yep, looks like we got this down. What are we going to have to add in? Yep, 2 squared is 4, right? I always put a box around it because students forget that it's there. You have to make sure that it's there because it has to be added back in. Now we do the other one. The y part. Okay, for the y part, what do we have? Y squared minus 6y. So what's half of negative 6? Minus 3. What are we going to have to add back in to force it to factor? 9. Okay? Is everyone all right with that so far? Now we rewrite it. Okay? Yeah, I moved the 60 over first. I divided everything by a 5. Okay? And then on each side, what do I do for each part? Half and square. Half of 4 is 2. 2 squared is 4. Half of a negative 6 is a negative 3. 3 squared is 9. Now put the pieces back together. And that's x plus 2, quantity squared. Y minus 3, quantity squared. Now we still have a 12 plus 4 and 9. So we'll put these all back together here. Put those all back together. And then we'll find our center and our radius. So let's bring those down. And that's an x plus 2, quantity squared. Y minus 3, quantity squared. And we've got 12 plus 9 plus 4. I believe that should be 25. That's going to be 25. And what is my center now going to be? Make sure you switch the signs. So your center is minus 2, positive 3, and the radius, square root of 25, which is now 5. Is everyone okay with the circles now? Did we have any other questions out of 2-1 or 2-2? Is that going to take care of those questions? Because there's only 3 more of the circles to look at of those equations. Now, just so we remember, this is a circle, and why is it a circle? Because that 25 was positive, right? If that 25 would have been negative, what would it be? Non-existent. Okay? If it would have been 0 here, what would it be? It would be the point minus 2, 3. So just make sure you know that, because question 10, I'm going to tell you right now, is not a circle. But you're going to have to tell me what it is. So 10's not going to be a circle, it's something else. Now we're going to move on, if we don't have any other questions. And we're going to look at 2.4. And 2.4 is functions. Oh, sorry, 2, 3, not 4. My mistake. Let's take it to the other class. We'll get through 2.4 today, but we're going to, sorry about that, we're going to look at 2.3 first, which is functions. Okay, now, when we talk about functions in mathematics, we talk about putting something in, and something else comes out. That's what a function is. I put in a number, I get a different number out. That's all functions do. One thing goes in, something else comes out. And we're first going to look at graphs. And then we'll look at equations of functions. And then we'll also talk about the domain and the range as well. So when we talk about graphs of functions, we have what's called the vertical line test. And you've probably heard about this before. Okay, the vertical line test, what we do is we draw vertical lines. And if any line touches the graph at more than one place, it is not a function. Okay, so we're going to be drawing vertical lines, and this is going to tell us if what we're looking at is a function or not. Now, circles were not a function. They were different. In mathematics, we work primarily with functions. We do a little bit with circles and other things, but mostly we talk about functions. If it's not a function, it's called a relation. So vertical line test, we draw vertical lines, and if any line touches the graph at more than one place, it's not a function. In chapters 4 and 5, when we talk a little bit about logarithms and exponentials, we'll have the horizontal line test. That's a later chapter. We're now just going to look at the vertical line test. So I'm going to give you some graphs. We're going to find out if it's a function or not. And then we'll also discuss the domain and the range. And this is up 1, 2, 3, 4 units. Okay, so first off, is this a function? Yes or no? Does anyone remember? This would be a function. Why is this a function? If I draw vertical lines, does any vertical line touch that graph at more than one place? No. Okay, so this would clearly be a function. Now, what about the domain? Domain is going to be your values of x. So we're looking at the x, not the y. So the domain always goes with x. Now, let's look at our graph. Okay, we're going to start here. And what happens as I go up? Okay, as I follow the graph up, it's going to the left, and it's also going what? To the right, isn't it? Right? See how it goes out in both directions? Since it goes to the left and to the right, your domain would be negative to positive infinity. The range is the y part. And that is your up and down part. Bless you. Okay, and when we talk about this graph here, well, this graph, it doesn't go down below at all, does it? And where does it start at? Starts at 4. Okay. And what is it doing? It's going up to positive infinity. So your range would be 4 to positive infinity, because the range is the y component. Domain is the x component. Yep, you'll always use brackets with these numbers, yes. Yep, so always bracket there. Now, what about infinities? Always parentheses, right? Infinities always get parentheses. Numbers in this section, when we talk about the domain and the range, they're going to get square brackets. Let's do another one. Is this graph now a function or not a function? Okay, this one is clearly not a function. Why is it not a function? Right, if I draw a vertical line here, what happens with this vertical line? That vertical line touches at 2 points, which is more than 1, so that makes it not a function, right? So it's not a function. What about the domain? Values of x. Yeah, very good work there. Okay, it looks like it starts at -3, and it's going to the right. So it's -3 to positive infinity. What about the range? Okay, yep, and what's going to happen here? Let's watch it as we move along the graph. What's happening? It's going up this way, down that way, right? As it goes to the right, it's going up and down both. So my range would be negative to positive infinity. Yeah, because we're only looking at the up and down part. Okay, so we're looking here. We look at what happens to this graph. And I don't care about the left and right part. I only look at the up and down. As I follow this green graph, what's happening to my fingers? One's going up, right? One's going what? Down. So as it goes up to positive infinity. And as it goes down to negative infinity. So the range is the y part, the up and down part. The domain is the x, the left and right part. Let's look at a circle or an ellipse. So 1, 2, 3, 4, 5. We'll go to 6 here. Okay, so let me kind of draw this here. Okay, so it's going to be about there, about there, about there, and about there. Okay, I'm going to draw this ellipse. Now this is going to be an ellipse. Try to draw it the best I can to make it fit in there. Is this going to be a function? Again, yes or no? No. Why is it not a function? Yep. Right? It will fail right there. What would the domain be? All right, domain, again, is the values of x. Yep, very good work. Yeah, negative, yeah, I put -1 there, but yeah. It would be -7 to -1, right? The x values. What about the range? Okay, and write it in the correct order. So the smaller value, yeah, you were correct though, smaller value goes first. So it looks like it's at about 1. And where does it go to? 6. So there is your range. So it's not a function. Right? Circles and ellipses are never ever functions. And the domain and range is going to be an interval. Now let's talk about, to finish up these graphs, let's talk about the increasing part, decreasing part, and the constant part, and what that means. Okay, so the increasing part, when I talk about an increasing component of my graph, that means I'm going up from left to right. I'm going to rise up. That means it increases. When we do a decrease, that means it goes down from left to right. And constant That means it stays the same. When we go to label these, we have to label on the x-axis. Very, very important, because a lot of times students label on the y part, and we don't want to do that. We have to label on the x-axis. So I'm going to give you some graphs. We'll probably do 2 of these, and we're going to label where it's increasing, where it decreases if it does, and where it remains constant if it does. So I'm going to give you a graph, and we're going to find out where it increases, where it decreases, and where it stays the same. So here's my graph. Now, what we're going to look at is we're going to look at this graph from left to right. So very important that we read it from left to right. Like we read our textbook, we read from left to right. I start at the leftmost corner, which happens to be here. Now, as I follow the graph, what am I doing? Going down. So that's going to be a decrease. Then we go across, bless you. So that's a constant. And then it goes down again. So that's another decrease, right? Decreases, stays the same, goes down. Does it ever increase at all? No. Now, when we put these together, if it's 2 parts, like the decrease, we use a U for union. So just like we did with the sets and interval notation, we use a U for union for the pieces. So we already said that there's no increase. What about the decrease? Let's do it next. Okay, where does it decrease from? Now, make sure we're careful when we label these. Right, we label on the x-axis. This is the x-axis here, right? Negative x, positive x. Okay, decrease. Where does it decrease from? Here. On the x-axis, what is that? That is negative infinity, right? To what? Negative 1. Then we use a U for union. And where does it decrease again at? Yep, I should have made that a little bit better. But that's going to be at 4. And where does it stop? Never. So it goes on to what? Negative infinity. But we label on the x. So it's here and here. We have to label on the x-axis. Now, where is it constant from? Yep, negative 1 to positive 4. I did not even label the y-axis because I do not want you to get confused and think you label it on the y-axis. It has to be labeled only on the x-axis. So only look at the x part. Don't look at the y at all. Let's do one more of these. And then we'll look at equations. So same concept here. Start here. Always start on the left. And you work your way to the right. So it's going down. And it's going up. So this is the decrease part. That's the increase part, right? Down and then coming back up. Is this function ever constant? No. So let's start with the increased part. Where is it increasing from? Okay, negative 5. And it's going to the right. So that means negative 5 to positive infinity. So we're going over. What about the decreased part? Okay, yep. Negative infinity to negative 5, right? And we use the square bracket with the negative 5. And do we have any constant at all? Nope, none. Okay, is everyone okay how we label these? So make sure you read them from left to right. Very, very important. If you read from right to left, it'll look the opposite way. So we look at these from left to right. Down is a decrease, up is an increase. The last part that we've got to cover in this section is going to be working with these equations. And we'll start by talking about an equation and talking about labeling it as being a function or not a function. So an equation is a function if it can be solved for x. Or sorry, not x, y. Sorry about that. So you're going to solve it for y. So an equation is a function if it can be solved for y. These are not functions. Y squared, y to the 4th, square root of y. Those are all not going to be functions. So an equation is a function if you can solve it for y. So no y squared, no y to the 4th, none of that. It has to be y by itself. We're not going to get the domain and the range of these. That can be done, but we'll look at those graphically later on. Okay, we're not going to be finding the domain and range because we'll look at them graphically later. So let's see if this is a function or not. How about 4x minus 2y equals 7? Do you think that's a function, yes or no? Yes. Okay. Why is it a function? Yep. You can solve it for y, can't we? Right? And we can do that. We know it's a function, and we can even solve it for y, because we can move that 4x over. And divide by our negative 2, which we'll be doing this in the next section. And so we solved it for y, right? You reduce that down. Negative and negative makes it positive 2 there. Minus 7/2. So we were able to solve it for y. If you can solve it for y, it's a function. In some cases, it may already be solved for y. Would this one be a function or not a function? Yeah, it's a function. Why is it a function? It has been solved for y, right? What about this one? Function or not a function? No. Why is this one not a function? Right? Because it's got a y to a power. So this one is not a function. How about this one? Yep, it is. Right? This one's a function. Why is this one a function? Can I solve this for y? Yeah, how would you do that? Yep, divide by x, right? As long as you can get the y by itself, then you know that it is a function. Okay, and the reason why this one over here would not be a function is in mathematics, when we talk about functions, one thing goes in, one thing comes out. If I was to try and solve this, what would have happened if I take the square root of this y squared? You get a what? Square root, right? And that is a plus or minus on that. So this would give you two solutions, because if I tried to solve this for y, I would get a plus or minus. And when we talk about functions, there's never a plus or minus. We want one number goes in, number comes out. Okay? Because we want it to be black and white. We want to make sure if I plug in the number 5 and you plug in the number 5, we get the same answer every time. Not 4 one day, 12 the next. So, function means you plug the number in, you get the same number out every single time. And if you had that square, that would make it a plus or minus. Now we can also replace y with f of x. So now we'll look real quick at function notation. Sure. Yeah, but see, when I do that, if you took the square root, okay, that would give you this. And we can't have a plus or minus, okay? When we look at functions, it has to be one part only, because this has two pieces. We want it to only have one. Right? So functions has to be one. One thing comes out. And that plus or minus would be, depending upon how you solved it, it would either be a positive or a negative. We don't want that. We want it to be one thing goes in, one thing comes out. So the reason why this is not a function is because of the plus or minus. Now a cube would work, but I don't give you cubes. I don't try to confuse you like that. But if this would have been a y cubed, it would work, because you don't have a plus or minus with a cube. But I don't even give you those. I just give you the simpler ones. Okay, so just remember, you have to be able to get the y by itself, and if you get a plus or minus, that means that it's not a function. Now, when we talk about function notation, we use f of x. So this is function notation, f of x. And this f of x, this can replace the y. Okay, so function notation f of x, that can be replaced with the y, or they can be used interchangeably. In some cases, it's going to be easier for us to use an f of x than a y. In some cases, a y might be easier to use. So just remember that f of x and y are the same thing. It's just that in some cases, it's easier to use a function notation when you're plugging values in than just using a y. So they mean the same thing. So now we're going to look at a couple of these where we're going to use function notation. So here's going to be the directions. I'm going to have you solve for y and replace y with the function notation f of x. So I'm going to have you solve it for y and replace y with f of x. So this is going to be our directions. Okay, this is what I want you to do. There's only a couple of these. I want you to solve it for y and replace y with f of x. And this is 2 through 4 in your homework. Okay, solve for y, replace y with f of x. Move that 5x over. So 2y equals now a minus 5x plus 8. We'll divide by our 2. And this, by the way, is what's called slope-intercept form, which we're going to be using this in the next section. Okay, when you solve for y, and it's a line that's in slope-intercept form, and this would be y equals now minus 5 halves x plus 4, and we need to replace that y with f of x, so we can replace that with our function notation, f of x. And that is all I want you to do. Solve it for y, okay, and replace y with f of x, because they mean the same thing. So if you see f of x, that just means y. They can be used interchangeably. Sometimes it's more beneficial to use f of x, and sometimes a y is the better choice. Let's do one more, and then we'll move on to the next section. Again, same directions. Solve for y. And replace y with f of x. And this one's very, very simple as well. Not much to do. All we need to do is solve this for y. And then replace that y with f of x. So let's move that 5x squared over. And now we've got y equals a minus 5x squared plus 4x. And we replace that y with our f of x. So now we've got f of x equals a minus 5x squared plus 4x. And that's all I want there. The next section should also be reviewed. And 2.4 is slope. And I know you're already familiar with the slope. So we're going to be looking at slopes of lines. And when I talk about the slope, that's going to be your rise over the run. And the rise is the up and down part, so that's your y. The run is the x part, left and right. So that's why the y needs to go on the top when we look at our slope formula. The x goes on the bottom. You should be familiar with this. This is also called m. Okay, so if you see a lowercase m, that means the slope. And I'm sure you've seen that before. A little m, that means your slope. The slope is rise over run. Now there are 4 different slopes that you may encounter. So I'm going to draw you 4 different graphs, and we're going to talk about each one of these. So we're going to be talking about the slope. Now the slope on these is either going to be positive or negative. And we can also think about it as an increasing or a decreasing function. So let's look at this line here. This line is a decreasing function, and my slope would be negative, right? Going down from left to right. What about the other one? What is it doing? Up. Up from left to right. It's increasing, so that would make your slope positive. Now there are 2 other lines that we have to concern ourselves with, and they are vertical and they are horizontal lines, and they have different slopes. Okay, so let's look at this one here. The one on the left. Is this one going to have a slope of 0 or an undefined slope? Which one? Does anyone remember? Well, okay. It's not undefined because this one would be undefined. This one's going to have a slope of 0. Why does it have a slope of 0? It goes left and right. Now, when we talk about our slope, right? Slope is rise over run. Are we going up or down any units at all? No. So that means a numerator would be 0, and any number, 0 divided by any number is 0. So horizontal lines have a slope of 0. Vertical lines, though, are the opposite. They have no run. So you're going to be dividing by 0. So these are undefined. So this one would be undefined. It has an undefined slope. Some instructors may say no slope, but I think that's confusing, so I like to use undefined, because we know division by 0 is undefined. So here's the 4 different outcomes that we can have. Positive, up from left to right. Negative, down from left to right. 0 is your horizontal line. Undefined is your vertical line. Now that we have the slopes down, we can talk about how to graph a line when you've got a point and a slope. So there are 3 ways that we can graph a line. We did the first one in 2-1, 2 points. If you have 2 points, you can connect them together and graph your line. You can also graph a line from an equation, which we're going to talk about later on today. Or you can graph a line when you have a point and you have a slope. So if I give you a point and a slope, we're going to graph this line. So let's see how we would graph this line. Okay, well, first off, we know it's negative on my slope, so it's going to be going down. It's going to be a decreasing function. What we do is we plot our point first. So the first thing we do with these is we find out and we locate 5, 2. So 5, 2 would be over 5 and up 2. From that point, this is where we're going to start. From that point, we've got a slope of minus 1/3. So that means we have to go down 1 and over 3. So we're going to go down 1 and over 1, 2, 3 units. And then I'm going to label it. So there's my point. And I like to label these. You don't have to label them, but I like to. Okay, we went down 1 unit, so that makes the y part 1. And we were at 5, we went over 3, so that makes it an 8. So my second point would be 8, 1. Now, once you have 2 points, we can then connect these together. So we can connect these together with a ruler or a straight edge there. And there's your graph. Let's do another one. And then we'll talk about how to find the slope when you're given 2 points. Okay, so this is how you graph a line when you have a point and a slope. And you plot the point. Make sure you still see it there. And use your slope. Let's do another one. Let's graph this line. How about I give you the point -2, 0. And let's say my slope is 5. So we want to graph this line. You've got a point and a slope, so we can graph it. Where would we begin? Well, the first thing we would do is we would plot our point. X and Y. So that looks like it's going to be on the x-axis here, and that's going to be over here at -2, 0. Is everyone okay with that so far? Because make sure you don't get the x and the y mixed up. I know a lot of times I see students do that on accident. X is the x part on the left and right. Y is the up and down. So it's back 2. It doesn't go up or down any. Now, what is my slope? 5. So I'm going to write that as a 5 over 1. And that's your rise over your run. So you're going to have to go up 5 units. So up 5. And then we're going to go over 1 unit. And then that's going to be our second point. And I'm going to go ahead and label that point. Okay, so we were at -2. We're going to add 1. So that makes it -1. And how many units did we go up? 5. So it's -1, comma 5. We now have our 2 points. And we can now connect them together. There's our line. Now it makes sense because when I look at the slope of this line, this slope is +5 and the line goes up from left to right. So we know we did it correctly. You can always double check things. Like this one had a negative slope and it went down from left to right, so we know we probably did it correctly. So you can always look at the graphs and double check yourselves. Now let's talk about how we find our slope. And when we find our slope, the y goes on the top because y is the rise. So make sure you remember the y part goes on the top. So our slope formula is this. Our slope formula is m equals, because that's your slope, y1 minus y2 over x1 minus x2. And the textbook may write it in a different order. They may put the y2 minus y1 over x2 minus x1. But it's the same thing. As long as the y goes on the top, x goes down below. That's the only important part. I think the other way is more confusing. So I always write with 1 and 2 instead of 2 and 1. So here's our formula. Now let's go ahead and find the slope when I give you 2 points. So we're going to find the slope when you're given 2 points. About -4, 3, and 9, -8. So I want you to go ahead and find the slope. Now we label our ordered pairs just like we did when we found our midpoint and we found our distance. So we're going to be labeling them x1 and y1 and x2 and y2. I always like to write my formula up so I have it. So m equals now y1 minus y2 over x1 minus x2. And I can now fill it in. Now be careful about double negatives. And make sure you put the y on the top. So that's y1, which is 3, minus a minus 8. That's your y2 over a minus 4. So there's that piece. Minus 9. Double negative, we know, makes that positive. And 3 plus 8, well, that makes it a 11, positive 11. And minus 4 minus 9 makes it a minus 13. And I'm going to write that for my final answer as a minus 11 over 13. So that is my slope. And that's a minus 11 over 13. I did give you several applications in your homework. I gave you 4 of them. I am going to work through 2 of them. So I'm going to do question 6 and question 8 from your homework. So I'm going to look at question 6 and question 8. This is 2-4 in your homework. Yep, 2-4. We're going to look at question 6 and question 8. So from April through December, the stock price of QRS Company had a roller coaster ride. The chart below indicates the price of the stock at the beginning of each month during that period. Find the average rate of change in price per, now per means divide, month, from June to September. So the first thing we need to make sure of is what our ordered pairs look like. We want June and we want September. Look at what we have here. Price per month. Now, per means divide. So that's going to be the price divided by the month. Look at our ordered pairs here. Price goes on the top again. Month goes down below. Okay? Price is on the top. Month is down below. We're going to do the same process that we just did. We need to get our ordered pairs. So let's look at our table and let's get our ordered pairs. Ordered pairs are going to go month, price. So what do my ordered pairs look like now? Let's write them out. If I write them out, what are my ordered pairs? Okay. Now, watch your months here. Okay, it starts at 1, so that goes 2, 3, 4, 5. So they want you to label these 6, 7, 8, and 9. So they want you to go ahead and follow this pattern. Okay, it starts at 1, and you label it. So my first ordered pair is going to be at June. June from April is going to be my 3rd month. And what's the stock price? $89. Then we go to September. And that's going to be, when I label it down, that's going to be month 6. And what's the price? 11. Okay? Now we can finish this. So now we've got our ordered pairs. So we have our ordered pairs. We can find the slope, which is the average rate of change. There's x1, and there's y1, x2, and y2. Okay, and this is going to give us our average rate of change for the slope. Average rate of change means the same thing as the slope. They're equivalent. Okay, let's plug our values in and see what we get. Okay, y1 is 89 minus 111. What about down below? What do we have? We have 3 minus 6. We're going to go ahead and subtract those. So 89 minus 111, that's a minus 22. And down below, 3 minus 6, that's a minus 3. And it says round it to the what? Nearest cent, so that's going to be 2 decimal places. And negative makes it a positive. 22 divided by 3, that is 7 point, if we round, 33. And what is that saying? That is saying that is $7.33 per month. So that's saying that on average between the months of June to September, that stock went up $7.33. That's what it says. That's what it means. Because we went from $89 to $111. So when we calculated it out, we got $7.33, and that's $7.33 per month. Slopes are always a ratio. A similar question is question 8. Okay, so question 8. A faucet is used to add water to a large bottle that already contains some water. After it had been filling for 5 seconds, the gauge on the bottle indicates 15 ounces of water. After 12 seconds, it contained 29 ounces of water. Find and interpret the average rate of change in volume of water per second. So, volume of water per means divide, second. Let's make sure we get our ordered pairs labeled correctly. So we want volume over the seconds. Y is on the top, X is down below. Right? When you look at our slope, Y is always on the top, X is down below. So what should our ordered pairs look like? The seconds is going to go first. The volume is behind it. Okay, so the second goes first. That's your X part. Volume is behind it. So make sure if they give them to you in a different order that your ordered pairs are correct. And the way I do that is I look at my ratio. Volume over seconds. So that means the volume is the Y part. Seconds is the X part. Now, what do my ordered pairs look like here? If you read it, it says 5 seconds, 15 ounces. So that's going to be 5, 15. And then the next one is a 12, 29, isn't it? Okay. And now we can calculate out our slope. So x1, y1, x2, y2. And our slope formula is y1 minus y2 over x1 minus your x2. And we fill it in, so we get 15 minus 29 over 5 minus 12. 15 minus 29, that should be a 14, isn't it? Yep, negative 14. I always double check myself. And 5 minus 12 makes it a negative 7. Negative and negative makes it positive. And that's going to be a positive 2, and that's going to be ounces per second. So when they talk about finding and interpreting it, that just means that you label it. And what does that say? And what does that actually mean? If I say 2 ounces per second, that means every second that bottle gets 2 more ounces of liquid. That's what it means. If it would have been a minus 2, you would be taking out or draining out 2 ounces every second. So on these, all you need to do is come up with your ordered pairs and work them out. Question 5, you just come up with your ordered pairs from the picture. Calculate your slope. Now we do have a few topics left to cover, and that's just going to be how to graph line equations. And so you should already be familiar with the slope-intercept form of a line. Slope-intercept form of a line is y equals mx plus b, and the m, well, that is your slope, and the b, well, that's your y-intercept. And that's 0, comma, b. What, do we need to look at the last one? Yeah, I can put that back up there if you need it. Okay, if you're still working the last one, I'll put that up there. Sorry about that. But we're going to be looking now at the slope-intercept form. When we go to graph lines, when you have an equation, you need to solve it for y. And then you get your slope and your y-intercept. Well, the y-intercept is a point. So we're going to graph it the same way that we graphed the point and the slope earlier. It's the same concept. So we'll just do a couple of these. We're going to graph these. We're going to find our slope and also the domain and range. So the directions are going to be graph, find the slope, domain, and the range. Let's look at this one. How about 5x plus 2y equals 6? So what I want you to do is I want you to begin by solving it for y. So anytime we have an equation, we need to solve that equation for y. And that's going to get it in slope-intercept form. So I'm going to move that 5x over. So now we've got 2y equals minus 5x plus 6. We'll divide by our 2. And now we've got our equation in slope-intercept form, right, which is y equals a minus 5 halves x. And 6 divided by 2, well, that is a 3. We need a point and we need a slope. We already know our slope. Our slope is minus 5 over 2. Our point is going to be the y-intercept. And that is 0, comma 3. So that 3 goes there. Now, how do we graph this line? Well, where do we start at? 0, 3, so that is 3 units up on the y-axis. And what are we going to do for my slope? Okay, my slope is minus 5 over 2. So that means we go down 5 units and over 2. So down 1, 2, 3, 4, 5. So that looks like it's about a minus 2. So we're going to go down 5 units. And then we're going to go over 2 units. And that makes my new point, if I label it, it looks like 2, comma, negative 2, doesn't it? Because we went down down 5 units over 2. We can now connect these dots together. And when we connect them together, that makes a line that's going down from left to right. So we know that we did it correctly because it's a decreasing function. And we also want to go ahead and get our domain and our range here. What would the domain and the range both be? They're going to be the same. And what are these going to be? Does anyone know? Very good work. Negative to positive infinity for both, right? Because you're going down and over, or up and over, right? You're going to negative infinity in both directions, both up and down. So my domain is negative to positive infinity, and my range is the same. All diagonal lines have the same domain and range, and it's always going to be this. Let's do another one. So we're going to go ahead now and find our slope. We're going to get the domain and also the range. Let's look at this one. Let's say we have y equals minus 3/2 x. And I picked this one on purpose just so we would remember there's no number on the end. So where do you think we're going to start at? 0, 0. Yep, just to make sure you remember, we're going to start now at 0, 0. What is my slope? Minus 3 over 2. And my y-intercept, yep, is the origin, which is 0, 0. Now we can quickly graph this out. We're going to start here at 0, 0. We've got a minus 3 over 2. So that means we go down 3 units. Over 2 units. And that makes my new ordered pair. You don't necessarily have to label these. If you want to just plot the point, connect them together, you can do that. But I like to label them. So my other point is going to be at 2, comma, negative 3. We can connect these together with our ruler or a straight edge here. It looks correct because it's going down. So we know that we probably did this one correctly. It's not a guarantee, but we're pretty sure that it's going to be correct because it's going down like it should. And what is your domain and your range going to be? Okay, the domain, negative to positive infinity, and the range is also negative to positive infinity. And the sign-in sheet. Is the sign-in sheet over there somewhere? Yep. Would you mind passing out the sign-in sheet? Yep. Sign it. Pass it around, please. Okay. One more question that we're going to look at, and that's going to be a constant function. And this one is very quick and easy too. But we do need to make sure you understand what a constant function is. constant function. Now it can be y or it can be f of x. Okay, so these are the same thing. I just want you to see that these are the same thing. And these are called constant functions. Okay, now what's the difference between this and the others that we looked at? Yep, these don't have any x's, do they? Right on this one. It's just a y equals. Now, if it's just y equals 5, or, same thing, f of x equals 5, that is a constant function. And how would we graph this? It's a constant function. Remember, constant goes left and right. Okay, they don't go up or down any. So if I wanted to graph this, these are the same. This would be up here at 5. 1, 2, 3, 4, 5 units up. It would be a horizontal line. Just like that. And we can still get our domain, and we can get our range, and the slope as well. What would my slope be? Does anyone know? 0. Right? Why is it 0? Because it's a horizontal line. So it's 0. What about your domain? Okay. Yep, negative to positive infinity for the domain. That's your left and right component. But what about your range, the up and down part? Okay, the up and down part is here, but what number is it stuck at? 5. So your range would be the number 5, right? Because it's stuck at 5. That should now let you finish up that homework packet. So what's your homework going to be? Well, your homework now is going to be 2.3. You can do them all, right? And 2.4. You can do them all. If you haven't picked up your homework from last time, I have it all up here. So if you didn't ever pick up your homework, put it over on this